Good evening, everyone. Yeah, good afternoon, everyone. Can you hear me? Can you hear me? Okay, we'll start without further delay. So, this is very important topics as far as GATE and all other competitive exam is concerned. Also, a knowledge in transient analysis, I mean to say DC transient analysis, will help you to determine or clearly understood the digital circuits analysis, analog circuits analysis, right? So transient analysis, you can say that it is very important topics not only for the competitive examination view, but for your understanding the other relevant subjects. Okay, so what do you mean by the transient analysis or transient conditions? Transient condition is not restricted to only circuit theory analysis, right? Transient exists in every field of engineering. Let it be mechanical, let it be economic, let it be your life, or let it be your lifestyle, let it be your environmental conditions. We often refer a, okay, don't worry, it is a transient phase of your life, like career. When you just started working for a company, or you just started learning the engineering, so we normally refer to as this is a transient phase. Transient phase ultimately dies down. Transient phase does not last longer. Ultimately, you will be reaching the steady state condition. So by this way, you by the time by this time you might have understood what is the transient. Transient is the when you are disturbed from the equilibrium. You are in a state 1, and you are going to have or achieve the state 2. The in between transition from state 1 to state 2 is the transient phase. Okay, now I want to be specific to a circuit. Suppose you have a capacitors and a resistors connected, and you have a battery of source, let's say uh, okay, 1 second. You have a resistors here, let's say R and a C. You have a switch here, and you have a battery source connected through a switch, that is your, let's say, 10 volt. Now at t equal to 0, the switch is closed. Do you expect that the capacitor will be charged immediately? No. As you know that the capacitor has to take finite time to charge it complete to 10 volt, and this is the, let's say, first the before switching you have 0 volt, VC equal to 0 volt, that is before switching. That is without closing the switch you have a VC 0 volt. Do you think that this VC will be suddenly 10 volt? You know that capacitor can store volt charges, and that charges when is the equivalent to a produce a voltage. Do you think that that 10 volt will be immediately appearing across capacitors when we close the switch? It is highly unlikely because there is a resistance here. So capacitor will normally charge from 0, 0.1 volt, 0.2 volt, 0.3 volt, 1 volt, 2 volt, 3 volt, and up to certain after certain time the capacitor final value will be the 10 volt. So capacitors, when you charging the capacitors, so the graph will be like this approximately, that is it charge and ultimately, so it will take some certain time. So let's say t1, so this time it will be 10 volt. Hers, can you hear me? Okay, you can hear me. Okay. So capacitor will take certain time to charge. That phase we call the transient phase. Ultimately the capacitor want to go from 0 volt to 10 volt, right? That is, this is your state 1, this is your state 2. We need that capacitor should go from state 1 to state 2 by this arrangement, and the time taken by this is the t1, that is the transient phase. Okay, transient phase, normally transient, okay, that is the important application of the transient phase is the control theory. You would have studied, okay, otherwise you will be taught here. So control theory, we say that the settling time, rise time, all these are parameters or properties of transient behavior of the system. That there we call it a system. Here in the circuit, okay, any system is made of the electrical elements systems. So transient, as I already told, transient is not only restricted to the electrical engineering. We can felt in every field, like mechanical field. So your economic, your career, your personal career, your suppose you are driving a bike 0 to 100, let's say 60 kilometer, you require time. Suppose you start here, you want to go some place, and you start from 0, 5, 10, 15, then ultimately reach a steady value, and then you drive, provided there is no traffic. Okay, then you slow down, then again, and you reach the your destinations. So this is a transient. Also, there are numerous examples you can elucidate the transient behavior of the systems or transient behavior of the circuits, or I mean to say your related to physical, not only physical system but the abstract systems. For example, you are sleeping, okay, nicely you are sleeping in your bed, okay, and you are having a sound sleep. Now suddenly your friend came and wake you up and told you to drive a vehicle. Is it possible? No, because you require certain time to come from the sleeping state to the fully awakened state. Sleeping and awaken. Okay, that is the transient. That is the transient. Once you understood the transient, then no one can prevent you analyzing the circuit or doing the problems in the. So first understand what is the transient. So I think it is enough. What do you do? What do you mean by the transient? Okay. So transient. Why transient occurs in electrical circuit? Why transient? The question is why. Why transient occurs? Why transient? Transient occurs due to the energy storing element. Due to energy storing. This is a interview question. Energy storing elements. We study transients a lot, but people are there who can't answer satisfactorily why transient at all. So we know that transient is not restricted to only electrical systems. For electrical system, transient is due to capacitor and inductor. These are they can, when they are connected in a circuit, they can store energy and dissipate energy. So for that behavior, they have a transient when you change from one state to other state. Similarly, for mechanical systems, you have transient due to the moment of that is your linear translational system, that is the mass and K, spring constant, spring. Or for rotational systems, so moment of inertia and coil spring constant, that is the torsional spring constant. Okay, because you know that capacitors in the inductor in terms of electrical element, they can store energy, so they cannot suddenly go from the one state to another state. For example, you have a capacitors and it has some charge inside it, so it is having a voltage, terminal voltage. You have a capacitors, you have some charges in the plate, positive charge here, negative charge, and you have a voltage, let's say V0, let's say 5 volt, and suddenly you want to change this voltage. It cannot happen because the dipoles are aligned in such a way that it retains the charge, because capacitors is made up of dielectrics, and as you know that dielectric have charges, so they are aligned due to the electric field and previously applied an electric field, so they have aligned, so there is no force to disalign, so they are polarized, so they have some voltages. This is the principle they are working. So when you try to suddenly change its behavior, it requires certain time to realign or reposition themselves to another direction in the same direction with a higher value of charges. So they require time. So that time is the reflected in the behavior, transient behavior, or in the circuit response. Similarly for the inductor, as you know that inductor, when you have a current flowing through this, it creates a magnetic field. It creates a magnetic flux when you have a current flowing through this, when it creates a magnetic flux around it. So this magnetic flux cannot be changed suddenly. Okay, so that indirectly we say that this current, whenever you try to change this current, it will oppose and create and added that current again, right? So that's why we see that the transient behavior exists in the inductor circuit. But there are certain conditions. Okay, these are the general case we say, but there are certain conditions, very few conditions, where you can say that we can change it suddenly. But what is that driving force that changes? Two special case we'll consider where we can change suddenly. So let me summarize what it says, the transient, that for inductor, current through an inductor, because flux cannot be changed in instantaneously, so current through an inductor cannot be changed or varied instantaneously. What does it mean? Let's say this is your time axis, this is your t equal to 0, right? Suppose you have some current just before, because why when you want to change the current, some switching action has been takes place. So when you have just before switching, just before adding some that is disturbing the equilibrium. Switching means what? You are trying to disturb the equilibrium. Suppose for t equal to 0 minus, that is the just before, this is the axis t equal to 0, you are disturbing the equilibrium, right? You are disturbing the equilibrium at equal to 0. So let's say you have an inductor and you have a current I, let's say IL is equal to, let's say 3 ampere. IO, this at t equal to 0 minus, that is just before the just before disturbing the equilibrium. So after, immediately after disturbing the equilibrium, we write like t equal to 0 plus, just that means just before, here is the t0 minus, here is the t equal to 0 minus, and here is equal to t equal to 0 plus. So the IL should be 3 ampere. This is the case, it's saying that current through an inductor cannot be changed instantaneously. Similarly, for the capacitors, okay, for capacitors, voltage across capacitor cannot be changed instantaneously. Okay, that means same as I told, suppose you have a capacitors here and let's say VC 0 minus, that is before disturbing the equilibrium. Let's say VC 0 minus is 3 volt, so VC 0 plus will be simply 3 volt. That's the very simple things to understand. Now there are two special cases. It can be changed instantaneously. One, see the connection like this. So capacitors here, there is a resistors, another capacitors, and another capacitors, and you have a switch here, and you have connected through a voltage source of V, and you have a switch here. At t equal to 0, you close the switch. At t equal to 0, you close the switch. C1, C2, C3. What happens here? Because you don't have register at T0 plus, whenever, because let's say VC1 VC1 0 minus, that is the before switching, equal to VC2 0 minus is equal to VC3 0 minus, all equal to 0. But what happens when, this is a special case I am talking about, what happens when you close the switch? When you close the switch, that will be at T equal to 0 plus, after the switching, the VC1 0 plus VC2 0 plus VC3 0 plus will be V. But here is the changing. If you go by the definition, voltage across the capacitor cannot be changed instantaneously. Here is changing because there is no resistor around this path. This bigger path, there is no resistors at T0 plus. So how it is changing? The question is, how is changing? As you know that there will be a charge flowing. Okay, there is a charge flowing to this capacitor C2, capacitor C1 at T0 plus. That is, there is no charge flowing through the R. So that charge will determine the how fast it is changing, why it is instantaneously changing. Okay, that it says that it requires an current of infinity. Okay, infinity current is required. That means voltage across the capacitor can change instantaneously. Condition is that infinity current of small duration. That means an impulse current will be reflected here. But as you know that charge transfer will be finite. If current goes infinity like del of t, so charge transfer will be finite. So because that charge transfers from 0 t equal to 0 minus to T0 plus, is the infinity current is required to change the voltage across the capacitor instantaneously. Okay, so you can say the first special case where we can change the voltage across the capacitor instantaneously is a short question or interview question. When you say that sir, voltage and voltage across the capacitor we cannot change instantaneously, they will counter you that is there any possibility we can change it instantaneously, immediately? Yes sir, it is possible if the current is infinity, and if the current is infinity, the charge transfer will be finite, and that will create a instantaneous voltage change across the capacitor. So as I told you, the exactly dual will happens in case of inductor. In case of inductor. Special case 2. See the situation here. Now initially the switch is connected at point A. Now at t equal to 0, it is changed to point B. So as we have studied that current cannot be changed instantaneously, but here you see that there is no resistors when you connect. Okay, I have did wrongly here the switch connections, because here resistor is there. Here the situation is like this. Situation is like this. Here it is connected at t equal to 0, it is moved to the point B. This is A and B. So here you can say immediately, let's say IL, this is your IL1, this is your IL2, this is your IL3. So IL 0 minus before switching, IL0 plus, IL1 0 minus, IL2 0 minus is equal to IL3 0 minus is equal to 0. I say that in this circuit it can change instantaneously. It can change instantaneously, that is IL1 0 plus plus IL2 0 plus IL3 0 plus is equal to I. In this case, the current through the inductor, here there is no resistor is connected to this inductor, so directly connected to the current source. It says that it is possible when an infinity potential is, for this infinity potential will be required. Okay. So as you know that potential is infinity, psi is equal to, that is the flux linkage will be minus infinity to infinity, V of t dt will be finite. If the potential Vt is the, this V is finite, if Vt is the impulse, that means an impulse of voltage or infinity voltage is required to change the current through the inductor instantaneously. Okay, so through special case, so very important, though question have never appeared from the special case, but directly indirectly it can come. Okay, so let us move to the our analysis with the help of simple circuits. So you can easily identify here in this question, it is not a special case because capacitor is charging through the anyway some resistors. You need to find, it has been given that, it is given that, very simple circuit for the transient analysis. It is given that the initial currents, okay, or you can say circuit is in relaxed state. In short word, circuit is in relaxed state, or in all the initial conditions are 0. Okay, I'll define, this is your I1, this is your I2, and this is your IC. So we'll do one by one. Okay, so before switching it is in relaxed state. Okay, before switching it is relaxed state. So and this is also VC. Okay, we need to find this. So I can easily say that I1 0 minus how much? 0. I2 0 minus 0. Are you able to understand this? What I am trying to say? 0 minus 0 plus, or I need to explain it again? Tell me. Because nomenclature is required. Naming, if you don't understand, then it will be you will be creating a mess. Okay, that's fine. Actually, I left the basic concept. Okay, we can also discuss after this example if you not understood that. Okay, I will try to that is explain through this example. 0 minus VC 0 minus 0, and okay, that's all, and IC 0 minus equal to 0, all 0. Now what happens when we close the switch? When I close the switch, the case is T equal to 0 plus, right? So what will be the situation for T0? See, this is the point calculation at 0 plus, 0 minus, and another one is the infinity. So this is the 10 volt. Registers no effect. This registers no effect. Now see here. I have told you this is not the special case, and voltage across the capacitors cannot be changed instantaneously. What does it mean? Before switching, what is the voltage? 0 volt. So I will replace by a short. This is for T0 plus circuit. This is your IC. Here, which means the circuit at T equal to 0 plus will be this. See, previous knowledge, or this is called the memory system has the memory, or network has the memory. What memory it was? That a capacitor is there, and the capacitors cannot voltage across the capacitor cannot be changed instantaneously. So we transport it to the T0 plus immediately after the switching. So now it is easy to find these currents. So you can easily see that I1 0 plus, which is equal to IC 0 plus, is equal to 10 upon 10, which is 1 ampere, right? And your I2 0 plus is equal to 0. Okay, 0. Similarly, you see that this 0, and what is the VC 0 plus? By short, it is a short. Why I2 0 plus 0? Because it is a short. This potential is same as this potential, and no current will flow the this 10 ohm resistor, right? Now tell me, what will be the situation? We are calculating a point T tends to infinity at steady state. T tends to infinity. As you know that as T tends to infinity, capacitor will be charged fully. So what do you mean by charge fully? When a capacitor charged fully, no current flow, it will act as an open circuit. The situation will be like this: 10 volt, 10, 10, and it will act as an open circuit because capacitor has been charged fully. This is the circuit for the open. That is the T tends to infinity. So now we can calculate I1 infinity equal to I2 infinity, which is 10 upon 20, that is 0.5 ampere. IC infinity, which is equal to 0 ampere because open, and Vc infinity will be the voltage. This voltage is same as the voltage across the 10 ohm resistors, have a potential division 5 volt very easily. So that is the step by step analysis required to do these type of problems. So I will summarize the things so that you can have a easy reference. First of all, you know that this is your T equal to T naught. Any by the switching can be happen at T equal to 0 or T equal to let's say if you delayed it by some time T naught, and just before is a T equal to T0 minus, and this is just after T equal to T0 plus. Once you understood this, let us elucidate the elements and some initial condition, and switching takes place at 0. So we say that switching takes place at T equal to 0. It can be at any point T equal to T1, T2. Okay. Now you have a resistors. First of all, the element. Okay. Then equivalent circuit. At T equal to 0 plus. Okay. And equivalent circuit or equivalent element at or equivalent T tends to infinity. Now suppose you have a resistors. First element, let's say resistors. Okay, resistors is the, so it don't change anything at any time. It remains same. Whenever you have a resistors, nothing is happening. Now you say the inductor. So two cases, inductors relaxed and inductor with a current IL. Okay, you have an inductor with a zero current and with a inductor without any current. So for zero current, you know current cannot be changed instantaneously. At T equal to 0 plus, it will act as a open circuit. When you have a current and you disturb the equilibrium, this is the equilibrium disturbed, it will act as a current source in the same orientation of the current. And T tends to infinity. When T tends to infinity, it will act as a, suppose it is open, so definitely it will act as a short. At T tends to infinity, it will act as a short circuit with some current. Some current flow. Similarly, it current can flow or not, it will depend upon. But here definitely this will act as a short with some modified current. It depends upon the circuit conditions. Okay, we will discuss in the how it changes. This will act as a short, this will act as a short at T tends to infinity, but their behavior will be determined by the circuit element, the circuit conditions. Third one is the capacitor. First case, without any charges. Okay, and with some charges, let's say Q naught, and the polarity of charge, positive charge, and V naught is equal to V naught equal to Q naught upon C. Okay, that is the capacitance, is the initial charge. So at t equal to 0 plus, that is the when you disturb the equilibrium, the capacitor will act as a short circuit, where it is relaxed. When it is relaxed, it will short. When it has a initial voltage, and the polarity will be the same polarity as the charge, and the voltage source will be V0. And equivalent circuit as t tends to infinity, it will as a open circuit. This will also act as open circuit, and the value of voltage depends upon the circuit conditions. This is the, if you understand this, then you can handle the question, okay, from the for the transient part, that is the point calculations, not the for all time, but t0 minus, t0 plus, and t tends to infinity. Mostly questions are concentrated like this. So as you are doing, so let us import one questions. Okay. This year, I think. Okay, I'll draw the question. Right. I have closed that question. Next. Can everyone see the questions? This is the GATE 2023. In the circuit shown below, switch was closed for long time. Okay, switch was closed for the long time. If the switch is opened at T equal to 0, maximum magnitude of VR in the volt, VR in volt is rounded up to the nearest integer, right? So you can see that. So because it is closed for the long time, so you can replace with the for T0 minus circuit. So the circuit becomes like this. As I told you, it has been lying for the long time. So R become R. These resistors become 1 ohm, 2 ohm, and this is the short inductor, and this is the 2 volt, right? So current here is the, so this current IL, because this is a short, so no current flows through the, this current is 0 ampere. So IL 0 minus is your 2 upon 1, that is your 2 ampere. Now switch is opened at t equal to 0 plus. So when the switch is 0, so I have told you that when you have an initial current, so inductor will be replaced with a current source. So now the circuit becomes like this when it is opened at t equal to 0 plus. This is open, this becomes 1 and this is the 2, and this will be act as a current source with the same orientation as shown below, because the initial the current is flowing through this, so 2 ampere. So 2 ampere source, and here is the 2 ohm, here is the 1 ohm. So it is asked that the maximum magnitude of the voltage, obviously at t0 plus the magnitude will be maximum, then it will discharge all the current, all the energy stored in the this inductor, it will be discharged through this resistance. So maximum will be at only t0 plus. So this voltage will be the VR is equal to, because the polarity shown here, so minus 4 volt. But many people have entered the minus 4 volt, including me. Okay, so you will get the 0 marks here, because we have not studied the full question fully, that is the maximum magnitude. This is the culprit here. So actual answer is the VR magnitude is equal to 4 volt. Okay, so this requires the practice and alertness in your exam. That means you should be into the your mode. You should be in the in the mode of inertia, that you are answering the question and read the questions carefully and noting down the whatever they are asked, that is the magnitude or absolute value, anything has been asked. So very easy question, you can easily fetch the 1 mark. So in the because it is the launch time, so I have disturbed you guys. We'll be studying more in the next class. So at least you have some grasping of the transient analysis by learning from my class. So next class we'll discuss the that is the initial rate of change, then for all range of time to the differential equation mode, and then we'll study a little bit of Laplace transform mode, so we can also do the question based on that. So for then please go through the transient analysis class again. If you don't understand, you can discuss in the group. So till the next class, most probably tomorrow, and see you in the see you and have a good day.